Alrighty, in this video today, we're going to be looking at 6.5, which is exponential and logarithmic equations. I found this section to be more of a review of all of chapter 6 than anything really new. But I'll hit all the highlights as usual and go over questions you'll see on the homework. All right, so I guess we'll call this part a recap of chapter 6. First thing we learned was the log rule. And it basically just stated is if I have it as log b of x equals y, it can be rewritten as b to the power of x and vice versa. If it's written as an exponential, I can rewrite it as a logarithm. We have learned that the inverse of f of x as an exponential is the logarithmic. All right, so again, remember, log is the inverse of an exponential. And then we talked about the different properties. So to highlight those properties, we saw that log base A of 1 equals 0. Log base A of A equals 1. We saw that log base A of A raised to the x is equal to x. And we saw A raised to the log base A of x is equal to x. We also saw the product property, which stated is if I have a log where there is multiplication being done, I can expand it so that there's addition being done. We looked at the quotient product, quotient property, which stated if I am dividing inside of a logarithm, I can expand it by subtracting them. We've learned that sometimes writing in an expanded form can simplify it, and condensing can be simplification as well. And we also saw the power property, which was the log base A of x raised to the r. Those powers can also be considered coefficients, and you would get the same value. So there you go. So that's everything that we've learned pretty much in chapter 6, along with a whole bunch of different type of word problems, which we'll review as well. All right, so let's first look at number 3, and we're just going to be using all these type of properties and what we've learned up to date to solve. So the first thing you're looking at is 11 raised to 3 over x equals 10. Now, obviously, you might not know what the answer is right away, so if it's an exponential function, we'll use the log rule, which remember is log base A of b equals y, which can be rewritten as a to the y equals b. All right, so I'm going to rewrite this. So this is now going to be the log of my a, which is this guy, of my y, or sorry, of my b, which is this guy, and it must equal 3 over x. All right, so all I did was rewrite this using this rule, and now I'm going to solve. So I can multiply both sides by x. So I now get x log base 11 of 10 equals 3. And then now I can divide. So log base 11 of 10. That will go away. So therefore my answer is this guy right here. And again, if this was a face-to-face class, this would definitely be the answer I would accept. But they want it round it to the hundredths place. So we're going to go type this into our calculator. All right, so in this one, I can see I have, we'll do control divide 3, and then control log, was it 11 of 10. And so we get 3.12. So we get 3.12. And that's it. So you just kind of have to work it to get x by itself. So again, we use these different rules to help us get to a point where we can use our algebra skills to solve. All right, we're done. That's pretty much what we're going to be doing today. So my goal is to expose you to a whole bunch of different types that you'll be seeing. So let's look at number 5. This is e raised to the 15 minus 3x equals 28. Again, might not be able to easily solve this, so we can use the log rule. So this would be the natural log, because that's what a base e would be, of 28 equals my y, which in this case is 15 minus 3x. So again, log base, so this is natural log of this number, equals the exponent itself. So now I have a easier way to solve this. So I'll subtract 15. And then I'll divide by -3. So in this case, I get the natural log of 28 minus 15 divided by -3. So let's go type that in our calculator. So again, that would be a controlled divide. And it was the natural log is the control e to the x button. So it'd be natural log of 28 minus 15 divided by -3. And so there was our answer there. I come back and I would get 3.89. Right? A couple things to pay attention to, just to make sure we haven't hit that situation. But make sure when you can plug it back in that you get the answer back. It's not such a big deal when it's in exponential form, but when we get into logarithms, we can't have a negative inside it. So I'll express that when we get to that point. All right, let's look at number 6. So this is going to be 10 to the power of 5 over x equals 150. Using the log rule, this is log base 10. Remember, I don't have to write a 10, so this log base 10 of 150 equals 5 to the power of x. If you write 10, it's not incorrect. Even beforehand, if you did log base e, the calculator would even recognize that as the natural log. So again, I'm going to multiply both sides by x. So I get x log of 150 equals 5. And then I'll divide by log of 150. So I get 5 over log 150. So then we'll type this into the calculator. And so this is, again, control divide. This will give us control log. Again, I don't have to write anything there. You can write a 10 if you would like, but this would be log of 150. Actually, no, it's 5. Sorry. So this is 5 divided by log base 10 of 150. Okay, and then we get 2.30. Let me come back over here. All right, so again, this will give us 2.30. All right, let's look at number 8. Number 8 says e to the power of 8x plus e equals 8 to the power of x plus 8. All righty, so let's look at this approach. Obviously, I can't make e and 8 the same, but let's approach it using the the log rule, sorry. So this would be natural log of e, so that's what that is, of this guy, so that's 8 e to the x plus 8 equals 8x plus e. Okay, so again, we rewrote it as natural log of base e of this guy equals this guy. Now, what we can do now is exponents can be written as coefficients. So now I have e, is it e to the x or is ex? Is ex. So this is ex plus 8. I'm going to put that in parentheses times natural log of 8 equals 8x plus e. All right. Then it gets a little tricky, but now I'm going to distribute this in. So this gives me e to the x of natural log of 8 plus 8 natural log of 8 equals 8x plus e. My next process is to get every term that has an x on one side and everything that doesn't have a term to the other side. So I'm now going to subtract 8x and move it over here. And then I'm going to subtract 8 natural log of 8 and move it over here. The rest of it will stay the same. So I get e to the x natural log of 8 minus 8x equals e minus 8 natural log of 8. I do this because now both of these terms have an x in it, and I can factor out an x. So that now gives me e natural log of 8 minus 8 equals e minus 8 natural log of 8. And it's almost the same thing, but not quite. All right, and now I'm just going to divide this guy here to both sides. And again, this would be a great actual answer, but now I just need to plug that in. So I'm actually just going to plug it into my calculator without switching over. I tell you what, okay, let me just switch over so you can see it, just in case you're unfamiliar on how to get just a regular E. All right, I'm not gonna be able to remember that. So what happens is the thing you're looking at, the screen goes away from me as well. And then I have to kind of quickly do it in my head again to see what we're plugging into the calculator. All right, so now we're ready. All right, so the answer that we got was a control divide, so it's a fraction. Okay, and then it was E, so the E button. This gives you an exponent, but I don't want an exponent, so I'm gonna go to the pi button here, and the E is located right there. So now I get E minus 8, and then natural log. So natural log of 8 on the bottom will now be e to the natural log of 8 minus 8. There we go. And so that's the answer that we get there. Again, it's like 5.293 if we round. All right, so again, this would be 5.93. All right, so a little bit more challenging, but the goal is to get it to a point where when you have multiple x's to get to just one singular x. All right, let's look at number 12. All right, so this would be e to the 3x minus 6 equals 10 to the power of x plus 2. Again, using the log rule, this becomes natural log base e of 10 to the x plus 2 equals 3x minus 6. So again, I'm going to take this, move it to the front. So this now becomes x plus 2 times natural log of 10 equals 3x minus 6. Distribute. So this gives me x natural log of 10 plus 2 natural log of 10 equals 3x minus 6. Again, get all your x's to one side. So I'm going to subtract 3x. And I'm going to subtract 2 natural log of 10. So everywhere there is an x, move it to one side. Non-x's go to the other. So I now get x natural log of 10 minus 3x equals negative 6 minus 2 natural log of 10. Don't forget that minus is attached to the 6. Now I can factor out the x. So now I get natural log of 10 minus 3 equals negative 6 minus 2 natural log of 10, and then divide. That will go away, and then this will give me whatever that is. So then I come back over here, do my control divide. Again, that's going to be a negative 6 minus 2 natural log of 10 over natural log of 10 minus 3. And so I get 15.21. When I bounce back over here, there we go. So again, that would be 15.21. Alrighty, so let's look at number 25. I get log base 5 of x equals 3. So sometimes when it's in logarithmic form, can't solve it, so we have to change it to exponential form. All right, so again, that's just going to be base 5 raised to the 3 equals x. Now I can see that this is just 5 to the third power. So 5 times 5 is 25, times 5 again is 125. No calculator needed, but this is where I'm talking about what you need to check. Take the value, plug it in for x, make sure you don't get a negative. Obviously, if I plug 125 in for x, I'm not getting a negative. So this one definitely does work. All right, let's try a more challenging one. So let's look at number 29. So this will be natural log of 2x minus natural log of 4 equals 3. So the other properties you learned was the product, quotient, and power. The quotient rule will be useful here because you always want to get it down to just a single logarithm. So what I'm going to do here is I'm going to write this as natural log. So I'm going to write it one time, and then it's the first divided by the second. Now that it's in this form right here, now I can write this in exponential form. So this would be e raised to the third power, and I'm going to go ahead and simplify this, x over 2. That's what 2/4 would be. All right. Now, all I got to do to solve for x is just multiply both sides by 2. So I get 2e to the third power equals x. And again, they want you to round to the nearest hundreds place. So I now need to go back and plug this part into the calculator. Okay, and again, this would have been, well, I didn't take a picture of this now. So 2 times e to the third. That's right. All right. And again, this time I can just hit this button because this time I do want an exponent. But if you hit this button, it's fine. Use the caret top there to make it a 3. So I get 40.17. All right, there you go. Let's see again. Let's see if I can find a more challenging one than that. We'll look at number 49. All right, this one says log base 3 of x plus 1 minus log base 3 of x minus 4 equals 2. All right, so again, since the bases are the same, I can condense this as one single logarithm. If they were not, We would not be able to do this process, but this will become x plus 1 over x minus 4, because it's the quotient property, equals 2. Now I can use the log rule. We're turning this into an exponential. So this is now 3 to the second power equals x plus 1 over x minus 4. And now I can just solve both sides. I don't like fractions, so I multiply both sides by x minus 4. This is 9, so I'm going to go ahead and distribute this. So this is going to be 9x minus 36 equals x plus 1. I'm going to subtract an x, and I'm going to add 36. So this gives me 8x equals 37 divided by 8. So I get x equals 37 over 8. However, they're good with that. Since it came out as a nice fraction, we are good with this. We do not have to try to figure out what it is to the hundredths place. Again, do check it. 8 goes into 37 more than 4 times. So when I plug it in here, I would end up with a positive number. But had this been like, I don't know, let's see, 31 over 8, that would be 3 7/8. Subtract it from fourth, that would give me negative 1/8. So therefore, this would not be an answer. But in that case, we are not at that situation yet. All right, let's get even more challenging than that. Let's look at number 58. This is e to the power of 2x minus 3x. Oh, I lied. 3e to the x minus 10 equals 0. All right, in this situation here, we want to do what we call a substitution. So I'm going to let u be whatever this middle term is. So in this case, e to the x, right? By doing that, I would then get u squared. Notice that 2 will stay because I only replaced e to the x with a u. So I only replaced this portion and this portion with a u. Everything else will stay. So this is u squared minus 3u minus 10. By writing it like this, I can now see, hey, this is just a normal quadratic, where in this case, I have e's and exponentials, and they get a little confusing. So we'll solve this one and then substitute back in when it's a little bit easier of a process. So again, quadratics can factor into 2 binomials, trinomial factors into 2 binomials, where the leading term will be the letter, which in this case is a u. And I'm looking for 2 things that multiply to negative 10, but add up to 3. Hopefully you're thinking 5 and 2. And then you go, all right, well, that has to be a negative. That's a positive. That multiplies to negative 10, adds up to negative 3. Then I come over here, and I now get u minus 5 equals 0, u plus 2 equals 0. So I get u equals 5 and u equals negative 2. Once you get to this point, now substitute it back in. So now this is e to the x equals 5 and e to the x equals negative 2. Now I can apply the log rule, and I'll turn this exponential into a log. So this is base e, so this would be natural log of 5 equals x. And then this right here would be natural log of negative 2 equals x. Well, one thing we talked about is you cannot have a negative inside of a logarithm, so this one is out. Do they want us to round? No. So we would leave the answer like this. But again, we would knock this one out because you cannot take a log of a negative. So the answer here is just natural log of 5. All right, let's do one more to make sure you grasp that those concepts. So let's look at number 59. This one is 2 to the 2x minus 12 to the 2x plus 32 equals 0. So what we're going to do, again, using substitution, I'm going to let u be 2 to the power of x. Again, letting it be this middle term. So that means I'm going to replace this guy so that now I have a u to the second power minus 12u plus 32 equals 0. So again, this trinomial will factor into two binomials. So my first term will be a u. What multiplies the 32 adds up to negative 12. I'm thinking a 4 and an 8, and then if they're both negative. So that would be positive 32 add up to negative 12. Set them both equal to 0. U would equal 4 and U would equal 8. Now substitute it back in. And now apply the log rule. So this is going to be log base 2 of 4 equals x. Oh, this should be an 8. And then this would be log base 2 of 8 equals x. Now remember what this means. This means 2 to what power gives me 4? And I guess you could have seen it here. I just kept on going with it. But hopefully you go, all right, that means that x equals 2 because 2 squared equals 4. 2 to what power gives me 8? Hopefully you see that that is a 3. I don't have to back substitute because I don't see anything that'll make it a negative. So there are your two answers. Alrighty, so that's pretty much it on that. And then they have a review of your word problems as well. So let's make sure we got those graphs, those concepts grasped as well. So let's look at number 76. It says, assuming a half-life of 5,728 years, how long would it take for 3 grams of carbon 14 to decay to 1 gram? Alrighty, so with this half-life, let's recall that formula real quick. I want to say it's like, hold on, we'll find half-life, half-life. We talked about half-life in what section? Normally they supply the formula for you. I think it was in section 6.2. Actually, I think they supplied it there as well. Yeah, okay. It's actually in the 6.5, but it is a sub t equals a0 times a raised to the t. So we know that in 5,728 years, this will be half this life. So we have to figure out this a first. So let's do this. So half of 3 would be 1.5 equals 3 times some random number raised to 5,728. Well, again, regardless of what numbers we would have plugged in, we get 1/2. Now we're able to solve this equation. We will do log of, oh, sorry, man, got ahead of myself. I'm so used to the rest of it. All right, so this is the one where you would raise it to the 1 over 5,728 or take the root of it. Again, I don't know the answer to that one, so let's use our calculator. And so over here, this would be, we'll just say 0.5, and then this would be control rooftop. Nope, I lied, it's just rooftop. Just want an exponent. And it's going to be 1 divided by, what was it, 5,200 and something. 5,728. So there is our A. So I get, I'll go with 3. And it's almost a 1. I'm going to write it all down because I don't want to have an error at the end. So the 0.999879. That's supposed to be a 9. All right, so there's my A. So then when I plug this in again, I now want to know 1 is how many grams I want. I started with 3. I now know my A is 0.999879. And I want to know how long that takes. So now this is going to be a third of what I want. All right, so now using the log rule, this will become log base 0.99879 of 1/3 will equal my t. So whatever this is. All right, so let's look at that in the calculator. All right, so again, this would be control log. What I'm going to do here in this little space is I'm going to do control answer. So I'll put that previous answer in of 1/3. So 1 divided by 3. And there we go. So we would take 9,078 or 79 years. All right, so let's go back. And that makes sense. It should definitely take more than 5,000 if that's half. 1/3 of that left would be less than a half. So it should take more time. But this would take, again, 9,079 years to go from 3 grams to 1 gram. All right, to review another one, let's look at number 77. This one says, suppose the population of bacteria in a petri dish has a doubling time of 1.5 hours. How long will it take for an initial population? So again, this is going to go back to that formula. So how long will it take for an initial population of 10,000 bacteria to reach 100,000? And you're trying to calculate T. So before we can figure this out, we got to figure out our A. So we know it takes 1.5 hours to double. So again, regardless of what numbers you put here, it's always going to be 2, because if you choose 10,000, then this will be 20,000. If you choose this as 1,000, this will be 2,000. So that's always going to be a 2, just like in half-life, it's always a half. And then it's going to be A to the 1.5 hours. So now this will become 1 divided by the 1.5. All right, so again, this will give me 2 raised to the 1 divided by 1.5. I'm going to keep it in hours this time. I think last video I turned it into minutes. But it actually doesn't specify. But I know on your homework, it keeps it in hours. All right, so there's my A. All right, so this would give me 1.5874. Again, I'm going to write the whole thing because I don't want to get an error. And then when I come back to this is now 1.5874 raised to the T. So I'm going to divide this by 10,000. And when I do this, I can see that that cancels that. And so I get 10 equals 1.5874 raised to the T. So again, using the log rule, this will give me log of 1.5874 of 10 equals my time. So again, when I come over here, I'll do control log, I'll do control answer, and then it was, oh man, what was it? 10, that's right, 10. Okay. So there is the amount of time. Right? So again, that's going to be 4.98 hours. All right, so let's look at number 79. This one says Wayne has 12,500 in a high interest savings account at 3.66% annual interest compound monthly. So recall that monthly is equal to my n, which would be equal to 12. Um, Assuming he makes no deposits or withdrawal, how long will it take for his investment to grow to this one? Remember, the question of this is a sub t equals p times 1 plus r over n raised to the n t. So my total amount I want to have is 15,000. My principal is 12,500. Then 1 plus my rate. Remember, this is my R, but I have to turn it into a decimal. So that's going to be 0.0366. Remember, you move it over to the left. So that's going to be 0.0366 raised by or divided by 12 raised to 12 times my t, because that's what I'm trying to turn. How long will it take? So to solve this out, this will become divide by 12,500. Using our calculator. I'm not going to switch back and forth on that. So that'd be 15,000 divided by 12,500 is 1.2. I'm going to go ahead and do this math as well. So that's 0.0366 divided by 12 plus 1 will actually give us 1.00305 to the 12t. Now, using the log rule, I can say, well, this will be log of 1.00305 of 1.2 has to equal 12t. Then you would take that result and divide it by 12. And so now my time would equal something. All right, so log of that. One point two. All right, so again, this is going to be control divide, control log. We got that first answer of 1.00305 of 1.2 divided by 12. That's it. So it takes about 4.98. Would that be years? Years, right? It's 12 months or in a year. So the answer will come out as years if you turn that into anything. So that's again 4.99 years, almost basically 5 years to increase by 20%. All right, got a couple more and then we'll feel pretty good about releasing y'all to the homework. So let's look at number 80. It says Ben and Casey both open up money market accounts with 4.9% annual interest compound continuously. So that's the A pert. A equals P times E raised to the RT. Ben opens his account at $8,700. So Ben has $8,700. While Casey, there's Casey over here, opens her account at $3,100. Part A says how long will it take Ben's accounts to reach 10,000? So that's going to be 10,000 says grand total equals his $8,700 times e to the, again, my R would be 0.049. Again, move that decimal 2 places to the left. So this would be 0.049 times t. So we'll first divide by 8,700. Let's see. So we get 10,000 divided by 8,700. is 1.149 equals e to the 0.049t. We would then use the log rule. So this would be natural log of e equals natural log of e of 1.149 equals 0.049t. And then we'll divide by 0.049 on both sides. So this will tell me my official answer. Again, I'm not going to switch over. I think y'all got it at this point. So this is going to be control log of 1.149 divided by 0.049. And so it looks like it would take us, or take Ben, about 2.83 years. All right. Then we go to Casey, or next that part says, how long will it take Casey to reach 10,000? So we do the same process, but for Casey now. So that's going to be 10,000 equals 3,100 e to the 0.049t divided by 3,100. So again, that would be 10,000 divided by 3,100 gives me 3.226 equals e to the 0.049t using the log rule. This would be natural log of 3.226 equals 0.049t, then divide by 0.049. And so now, again, just going to type it into the calculator. 3.226. It's going to take her 23.9 years to reach 10,000. All right, part C, how much money will be in Ben's account after the time found in part B? Okay, so then all we got to do now for part C here is take this. So A would equal $8,700 times e to the 0.049 times 23.9. So again, plugging that in the calculator, they want to basically see if she would have waited until that point, where would Ben be then? Right? So that would be 87 e to the 0.049 times 23.9. He would be at $28,062.20. All right. So almost triple the amount of money Casey would have at that time. And they put money in at the same time. So start young, put money in now. You'll have a lot more money when you're older. Try to keep it and spend it as a young person. You won't have much money as an old person. All righty. Next thing I need, last question, and this will just wrap it all up. Number 81 says cesium-137 has a half-life of approximately 30 years. So half-life would be 30 years. How long would it take for 160 grams to become 159 grams? So again, the first thing we want to do using this half-life, ace of 0 AT, right? Or something like that. All right, so again, we know that this is going to equal half. We're looking for the A, and we know it happens in 30 years. So we'll do 1/30th first. So we need to figure out what is 0.5 raised to the 1 divided by 30. So that right there would be 0.97716. Now we can figure out what this answer is going to be. So now this time I want it to be 159 grams. I start at the 160 grams of 0.97716 raised to the t, because that's what I'm trying to calculate. So 159 divided by 160 gives me 0.99375 equals 0.97716 raised to the t. Using the log rule, I can now take log of 0.97716 of 0.99375, and that will tell me how long that would take. 30 years to do that? I'm thinking maybe a year. Let's see. So this will be 0.97716, 0.99375. Oh, not even quite. So this would actually, to go down 1 gram, would take 0.27 years to go down 1 gram. Oh, did they say it? They didn't, but on your uh, test or your homework, it's going to be in days. So to do that, just take that number and multiply it by 365, because that's how many days are in a year, and it'll come out to about 99 days. Actually, I think it'll accept both now that I think about it. So I think it'll take this answer, but I think it would accept this answer as well. All right, other than that, that is pretty much all 6.5 was. So it's really just a review of what you've done in chapter 6. As always, if you need any help with any of these questions, feel free to reach out. Until the next video.